Saxon Algebra 2, Lesson 93 is called the discriminant. We're going to get to that in a minute. Let me point out that this is our last week before the midterm coming up. We'll have regular lessons this week. A week from, well, on March 28th, I should say, I will drop one last video that will be a review for the midterm. If you're a local student who's taking that midterm with me, if you are not a local student but you'd like to take my midterm, just email me and I'll send you a PDF of it, and you can enjoy that process with us. Local students, it'll work exactly like our previous midterms. 10 problems. I'll drop it off at your house. I'll give you 24 hours to work it. I'll come back. I'll drop it off on Wednesday of, let's see, it'd be Wednesday the 30th, and then you can finish it sometime between midday on Wednesday and midday on Thursday, and then I'll come pick it up from you. Then we'll take off a week for spring break, and we'll be back on April 11th to start again. You won't have any homework due that day. You don't have to do any homework over spring break, but April 11th is when we'll get back to the new lessons, right? And as you can see, we don't have a long way to go. We've really worked hard, and we will be done soon. Okay. The discriminant is a simple, straightforward, and kind of fun lesson, but in order to understand it, we have to go back to our basic friend, the standard form of a quadratic equation, right? And we know that if you solve this thing for x, if you just complete the square and rearrange all of this, you'll get something that looks like this. Right? We call this the quadratic formula. I call this the man-eating dragon. And we know that you can take these letters, A, B, and C, whatever numbers are in there, and you can just plug it in, and that will give you the answers to this equation. Now, we know that there are two different kinds, or three rather, there are actually three different kinds of answers that you can get. The first one, and I'm going to number these. The first one is you'll get that x equals just one real number. Now, that's very rare. What's more common is that x will equal two real numbers. We get that a lot, right? X equals -5/2 and 12/2, something like that. The third one we've gotten used to, x equals two complex numbers. Oh, that's when we end up with an imaginary number. And we end up with an a plus bi kind of thing. Remember that when we have two real numbers or two complex numbers, it often looks like just one number because we use this symbol, right? The plus or minus, to show that it's actually two numbers, even though it just looks like one. These are the three different kinds of answers we can get to a quadratic. Oh, I want to just say this. This number one style of just getting one real number is very rare. We don't see that one much. It's usually two or three, right? The discriminant is a special small calculation we can do that predicts which answer we will get. Okay, so the discriminant itself tells us whether we're going to get one real number, two real numbers, or two complex numbers as the answer to our problem. And what's cool is that the discriminant, this mysterious thing, that I've been talking about is simply this part of the quadratic formula. We say the discriminant equals b squared minus 4ac, which is exactly what that is, right? Not the square root part, just the pig, okay? If b squared minus 4ac is 0, then x equals situation 1. We will have one real number solution. If b squared minus 4ac is a positive number, then we will have scenario 2, two real number solutions. And if this little part, this b squared minus 4ac, is a negative number, then we will end up with scenario 3, where we have two complex numbers as our solution, okay? So this tells us exactly how the discriminant, we calculate the discriminant, and then we look at this list, okay, right here. This is all puffy cloud of knowledge. But if our discriminant is 0, then it's situation 1. If it's a positive number, then it's that. And if it's a negative number, then it's that, okay? So let's put it to use and see what we find. Example 93.1. What kind of solution does, and then he gives us this, have, and he says do not solve, John does. What he's saying is, I don't want you to work it all the way through. I want you to just use the discriminant to predict the answer. Okay, so he gives us this. Well, this is a mess. This is not gonna work. We can't take our A, B, and C values from this. We have to clean it up, right? I'm gonna swim this across. When you change sides, you change signs. Same for this one. Okay, that tells me that A equals 1, B equals 4, and C equals minus 2. Okay, this is just as if we were going to solve this, but we're not gonna go all the way. Okay, now we know that all we want is b squared minus 4ac. So, plug in. 4 squared is 16. This becomes plus 8 equals 24. That is a positive answer, right? To our discriminant. So we go back to our chart, which I have another copy of right here. I'll show you this one. If this number is positive, then that means we have two real number solutions. These are last year's notes that I can just use to reference. So that tells us that the answer to this problem is that we will have two real number solutions. This is what John wants for his answer, is words describing which of those three scenarios we've got. Beautiful. Let's do another one. There are how many in all? Oh, just 2. All right. What kind of roots? That's another way John can ask the same question. What kind of roots? Last time he asked what kind of solutions. Does the equation, and then he gives us a scrambled mess, have? Do not solve. Again, do not solve is your clue to use the discriminant, because he's saying he doesn't want you to go all the way through. He just wants you to tell us what kind of solution, not find the solution. All right, John gives us a mess. If I were you, here I'm going to copy it. If I were you, I wouldn't copy it like this out of the book. This is just messed up and wrong, right? We know we want everything on the same side. I see that minus in front of the x squared term and I think, well, that's the one I want to change. Because we can swim them all to the right or the left, whichever we think is better. I'm going to pull everything to the left. So that means I've got positive 3x squared minus 2x, and then this one has to come across 2, so it's plus 8 equals 0. A equals 3, B equals minus 2, C equals positive 8. The discriminant is just b squared minus 4ac. Use some buckets to set that up. B squared a c. All right. This is 4 minus, oh boy, 12 times 8. Let's do it that way. You can multiply these together any order you want. 12 times 8, I know that though it's a 96. And I'm double checking my minus signs. There's just the 1, right? This is a minus sign and then that's a minus sign, but this stays negative. So this becomes minus 92. That's a negative answer. I double check it on my list. If the discriminant is a negative number, then I have 2 complex number solutions. So that's what I write here. 2 complex number solutions. And that is the answer John's looking for. Again, he doesn't want to know the value of the discriminant. He wants you to use that number to predict what kind of solutions you'll have if you were to solve this. All right, that's all there is to it. What you need to make sure, what most students do, the fatal flaw in their logic, most students remember that, oh yeah, this is the discriminant. You just solve that little piece of it. But what they forget is you have to know what that, how to interpret what that means, right? If it's 0, if it's a positive number, or if it's a negative number, and then you know if it's 0, it's 1 real number solution. If it's a positive number, it's a 2 real number solution. And if it's a negative number, it's complex, right? These numbers help you link the value of the discriminant to the type of solution, right? So you make sure you understand how these 1, 2, 3s connect. Positive number means real. No, 0 means 1. Positive means 2 real. Negative means 2 complex. Okay, I'm done talking. Bye.